All right, so now that we've got our ocean divergent crust happening, I want to do a continental divergent boundary next. It's going to be very, very similar to what we did with the ocean crust, but this time let's do it in green to match our first diagram that we did of the Earth's layers. So let's do the continental crust in green. And we're going to start close to the center, but a little bit further apart than what we did with the ocean crust, because I want to show some interesting features here. Okay, so we're going to start like this with two angled sections of green, just like this, but further apart than we did with the ocean crust. So we're going to bring that down a little bit. Not too far yet. So if you are only doing the outline, don't quite draw it all yet. Okay, you're only going down a little ways. Now, what we're going to do is we're going to come up and kind of go like this again. Okay. Now, this is a phenomenon called faulting, where as the new crust is forming and the old crust is being pulled apart, the crust in the center of this feature falls down. So it kind of creates these jagged fault features. Okay, and this is on the continent, remember? So this is open to the surface. You can go visit fault fissures like this, these divergent boundaries. You can actually, the most famous one is in Iceland. So we've got the Icelandic Rift Valley. Okay, so remember on the ocean floor we called those mid-ocean ridges. For that raised part. But on the continents, they're called rift valleys because the section in between kind of creates a valley feature. All right, so we're going to trail this one off. And remember, both sides of a rift are going to mirror each other. Okay, in a perfect world, they would be mirror images on both sides. In reality, it's not quite that perfect, but we're going to mirror them on both sides. Okay. Now, another famous rift valley is the African Rift Valley. Now, the Red Sea is actually a large rift as well. So where these rifts open up on continents, they're eventually going to fill in with ocean water and form new ocean basins like the Red Sea. Okay, so what's actually forming at these rifts is not new continental crust, but instead new ocean crust. Okay, so we're going to go to our black. That was what we used for ocean crust, and we're going to add a little bit of new ocean crust, following that same pattern, this kind of V shape here. Okay, so what's actually forming in these rifts is brand new basaltic ocean crust. So we can kind of bring that down underneath our continental plate. Okay, so we've got continental crust being pulled apart, opening up this rift, and the magma that seeps out is basaltic magma that's going to form new ocean crust. Now, in parts of Iceland, this is already pulled apart enough where ocean water is filling in. You can actually go scuba diving between two tectonic plates, which is on my bucket list of things to do before I die. I think that would be really, really cool. In instances like the Red Sea, it's already pulled apart and ocean water's filled in. So then you have on the coastline the remnants of the old continental boundaries. Okay. So there gives us some new basaltic ocean crust forming just on the underside and in the middle of that. And of course, what's actually happening there, what's coming out of it is lava, is magma. So let's add some red, just like we did with our ocean divergent boundary. Get all the green off. Okay, let's add a little bit of red in here. Simulate that magma coming up from the mantle. All right, we're going to continue it on out here because that is the, remember that's that uppermost part of the mantle, which is the bottom of the lithosphere. Pull that on over all the way to the side of our diagram. It's okay if it blends together because that's what actually happens in real life. That's what happens to these layers of the Earth. They don't really have a sharp designated break. They blend into each other. Okay, because it's hot and they're melting, becoming intermixed. Alright, so that kind of finishes up our lithosphere section. The underside of the lithosphere, the upper part of the mantle. Okay, and again, just like our ocean crust, this is from that mantle convection coming up from underneath, all the way down at the core. The mantle has been slowly rising for millions of years until it reaches these rifts and it opens up. So we get a little bit of volcanic eruption here in the center. Alright, so just make that volcano explode. A little more red here. Blend it out. Alright, so let's use our red also to label or draw in the arrows for that mantle convection. Remember, mantle convection is coming up here. It's coming up. It's also turning and moving away from those rifts. Some of it gets pushed out as new crust. The rest of it gets pushed aside and follows that plate as it moves. Now, I mentioned that Iceland's going to be slowly ripped in two, and eventually it's going to fill in, the Atlantic Ocean is going to fill in between it, and instead of one big island of Iceland, we'll have two. But this isn't going to happen for a very, very long time. The plates, we can actually measure their movement now using GPS and satellite tracking, and we know that they move at about an average rate of 2 centimeters every year. It's not very fast. The fastest plate movement's about 14 centimeters per year, which is pretty considerable. But still, even by that metric, it's not very fast. If you want a good comparison, it's about how fast your fingernails grow. So how often do you clip your fingernails? You can kind of imagine that's how far the plates have moved since the last time you clipped your fingernails. Something to think about. You'll probably never see clipping your fingernails the same again. Okay, so that's basically finished with that. We're going to add in a few more features. Just like the hydrothermal vents that are happening under the ocean, we actually have hydrothermal vents and geysers that happen on the continent. So Iceland and places where this is happening are known for hot groundwater. Okay, so we're going to use blue again. Seeping up and being pressurized and heated by this magma that's very close, and they erupt out of the ground as geysers. Okay, so we have, again, hydrothermal activity where hot water escapes as these geysers. I'll put a couple of these here. Now, because of this phenomenon, Iceland has a lot of geothermal power generation. So they use this magma that's very close to the surface, creating these geysers and hydrothermal pools. If you've ever heard of a hot spring, that's essentially what's happening there. So those hot springs and hydrothermal activity can be tapped into, and they use it to generate electricity. There's even, if I remember correctly, there's a restaurant somewhere in Iceland that they pipe hot steam from underground into their oven, and they cook everything with underground heated steam, which is really cool. They also have really cool heated roadways. So in the winter when it snows, the hydrothermal temperature is brought up and melts the snow off the road, which is pretty cool. Okay, so both the continental divergent boundary and the oceanic divergent boundary have similar features, and eventually the continent is going to separate enough so that it's going to look like our ocean to ocean divergent boundary. Okay, so we have rift valleys on continents and mid ocean ridges under the ocean. Okay, so we're going to label this diagram's features. Remember, this is continental divergence, new crust forming in the center, older crust further out. We've got faulting, geysers, fissure eruptions, and that mantle convection underneath pushing up and creating these new features. Okay, so that finishes diagram set number 2. Next, we're going to talk about the different forms of convergent boundaries.